Hi everyone, welcome to another episode of Rick Tech. In this episode, I am going to discuss about how to calibrate TechScope EZW2 new Text EMI console and introduction of EMI inspection. Mainly, electromagnetic inspection is used to find out the transverse flaws or a transverse defect in tubular goods like a drill pipe, tubing, casing, line pipe, etc. The TechScope EZW2 console can detect the transverse defect as well as valve reductions. These both defects, valve loss and transverse defect, can find out through the Nutex. Nutex is the brand. Nutex TechScope EZW2 EMI console. It is one of the traditional machine. It will provide the defect through the chart on graphical representation. First off, I will introduce the console. the tubular goods like drill pipe, tubing, casing, line pipe, etc. from the size of 238 to 658 inch. The buggy head also designed for EMI inspection according to the size of 238 to 658 inch tube body. In between that, hold the pipe. You can inspect through this console, and each size have specialized sensors, means specialized size sensors. That 8 number of sensors will cover the whole pipe. So each sensor's dimension will be different. In 3.5 shoe is different, 5 inch is different, 4 inch is different, 5.5 is different, 658 is entirely different. And coil also, you can select the appropriate coil. Third one is buggy drives. Buggy drive help it to move the buggy head through the pipe. It consists of 2 high-speed motors, that provide the drive with coil and buggy head through the pipe. Buggy drive also have 2 arms. That is the place to sit the coil. Buggy head and arms also attached to drives. It will drive throughout the pipe with 50 to 60 foot per minute. And next is coil. Coil is also same 9 inch and 11 inch. 110 volt DC coil for using to detect the transverse flow. These coils are consist of 1800 ampere turns DC coil. These coils will provide the magnetic field throughout the pipe. Magnetic coil rides on the buggy head. This coil will provide the magnetic power through the DC current. Coil current is controlled by console, EMI console. Normally, copper wires are used to wind the coil with 1800 ampere turns or 1800 ampere turns. That will provide the sufficient magnetic field for the inspection. The cables. Four cables needed for, or 4 types of different cable needed for the EMI inspection. First is 3-pin cable that was energized the console with 110 power. A 3-pin power cable also male only cable. One end is male and another end is plug point. Next is coil cable. It was a 2-pin male and female cable. Coil cable is transfer the power, DC power from console to EMI coil or EMI DC coil. It's a male and female connection. The coil have a male connection and the console have a female connection. The 2-pin male and female connector is used to coil cable. It will give the power to energize the coil. Connection is from console to coil. Third one is drive connector. Buggy drive cable. It have 4-pin connectors have both ends to transfer the DC current to drive to energize the motor or to give the power to motor for forward and reverse running. In console have female connection. This drive cable have male and female connectors on each end. The console have female connection. So male connection needed to use to connect to the console, and buggy drive also male connection. Female cable can use the buggy drive. Drive cable help to transfer the DC power from console to drive and to drive the buggy head. Next is signal cable. It consists of 24-pin female connector on both ends. These cables will help to transfer the electronic pulse or electronic signal from buggy head to console. How the shoes are generating electronic pulse or signals. If there is any surface discontinuity, the magnetic flux will come out from the discontinuity, so that there is a magnetic field. If the magnetic flux is come out from the tubular body or calibration pipe, any tubular product, there is a magnetic field. The shoes are a coil. Any conductor will cut the magnetic flux. The conductor will produce the small amount of electricity. That electricity is sent to console. Console will amplify and convert it to graph. These are the main thing happening in the console. So the signal cable have both female connector, console and buggy head have male connectors. So if one side is damaged, the signal cable, you can swap it. So both side connectors are same. These are the 4 cables. First is a 3-pin cable for power. Second is a 2-pin cable for coil. Third is 4-pin cable for drive system. And fifth is 24-pin cable for buggy head. Next is calibration standard or test pipe or calibration pipe. Anything you can say, it's a single standard pipe. This standard pipe consists of 8 numbers of artificial holes on spiral pattern cover the whole circumference. 5% of wall loss, artificial wall loss. The hole is 1/16 inch diameter, full penetrated hole. The test pipe contains 1/16 inch diameter plus or minus 1/64 inch tolerance, full penetrated artificial hole with spiral pattern on hole circumference, and also have 5% of wall loss, artificial wall loss. Internal or external artificial wall loss are artificially made on pipe. Each size of buggy head have their own standard test pipe. Because I already discussed, each shoes are different size. So these shoes will cover hold the circumference of pipe. Each size have different shoes and each buggy head have different pipes. If pipe is using 238, you have to use the 238 inch buggy head. You have to inspect a 5-inch drill pipe or 5-inch casing. You have to use the 5-inch test pipe and 5-inch buggy head. If you are going to inspect the 238 inch tubing or pipe, drill pipe, you have to use the 238 inch head and 238 inch test pipe or calibration standard. So which size of the pipe you are going to inspect, you have to calibrate the console with the same size standard pipe and buggy head. So that 8 full penetrate hole with a spiral pattern is covered the whole circumference of standard pipe. The distance between each hole should be same. So these are the simple technique to find out the calibration pipe or standard pipe is manufactured under the criteria. The circumference into pi divided by the value of pi is 3.14 divided by 8. The pipe diameter into pi or 3.14 divided by 8. Then you can get the distance between two holes. You should ensure that these shoes are covering the circumference, whole circumference. Next is air jack system. 2 air jack is needed to raising and lowering the pipe. Pneumatic used or air operated jacks are used to raising and lowering the pipe. 2 different type of jacks are provided in the new tech, heavy duty and one is light. This is heavy duty for heavy operation like a casing, and normal can use for normal operation like drill pipe, tubing, etc. The compressor will provide the air. There is a valve to open the jack and closing the jack. Means to raising the jack and lowering the jack. Some of them have a foot valve. Some of them have a handle valve. It's a simple one. Compressor will produce the air and that air can use to raise the jack system. That's it. How the EMI consoles are showing the defect through the graph. This EMI can do only in ferromagnetic pipes. There is 8 numbers of sensors or shoes covered with the full circumference of pipe. When give the electricity to coil, coil will energize with the magnetic power. That magnetic signals or magnetic flux will travel through the pipe. When there is a discontinuity, material discontinuity, magnetic flux will leaking or magnetic flux will come out. The shoes are passing or shoes are cutting. Shoe is a solenoid. Solenoid means it's a circle shaped coil is attached to a aluminum container. It's called a shoe. That shoes will cut, that coil will cut, or that solenoid will cut the magnetic flux. So then there is an electricity will produce. That small amount of electricity sent to console. Console will amplify the electronic signal or electric signal, then converted to graph or graphical representation. Each shoes have their own amplifiers. Means each shoes have 8 single amplifier circuits or single amplifier sections that will convert it to the 8 shoes signal into graph. These are really happening inside the console. For to energize the coil, the console will give the power, and for drive the or buggy head, the console will give the power to drive the motor. I will introduce the console. The console will working with 110 AC current, and all the body is metal. There is a power switch and 3 circuit breaker is also there: drive, coil and logic. Then next one is male signal connector attached to the female cable connector. Next is drive connector. It's a female connector with 4 holes. The 2 is using to transfer the signal and 2 is vacant. That 4 connectors only 2 is using. And the next is coil port. It is a female connector with 2 holes. You can connect the coil cable with 2 male pin. Next port is 3-pin male port. You can connect the 3-pin cable, 3-pin power cord to the console. Console is always working with 110 power. If you don't have 110 power, you have to use the transformer. Isolated transformer is better than normal step down transformer. All the connector ports you can see in the left side of console. On right side of the console, there is only one control is there. It was mag control. One variac is there. It will help to increase or decreasing the mag current. In the clockwise you can increase the mag current, and anti-clockwise you can reduce the mag current. On top of the console have left side is transverse adjustment, and right side is wall setup adjustments. There have left side is a transverse adjustment. It contains 8 numbers of potential meters to control the amplification of electronic signal, and there is 8 numbers of toggle switch that will help to on and off the shoes. Switch is on, the electronic current will pass to amplifier. Switch is off, it will not. And each potential meter is representing each shoes. There is 8 numbers of shoes are there. That 8 numbers of shoes are having 8 toggle switch to on and off the signal. There is a glowing LED or optical representation and audible representation that will notice which shoe is passing the threshold line. Threshold line I will explain you in chart section. LED will help you to find out the kicks passing the threshold line, and toggle switch will help you to on and off the line. Shoes, and potential meter or potential control will help you to adjust the signal to achieving the kick height to threshold. And below of this section, 4 potential meters are there. One is signal conditioning system, SCS level. That will help the signal is passing beyond the, it will show on third section of graph. In graph have 4 sections. First is wall monitoring representation chart. Second is SCS section chart. Gain. Gain is helping to increase and decrease the value. There is also 2 toggle switch that will help to show the line for adjustments. Normally, once you set the line, it will run always the same path. If you want to increase or decrease the value, you should run the chart, then hold this control, this toggle switch. Then it will show where the exact position of the line. Then you can adjust the control to increase or decrease, to go up or down the
SCS level.
And next is buggy control. These potential meter help to increasing and decreasing the speed of buggy. And the next switch is reset. It will reset all the functions. Next is coil control, printer control, and buggy control. 3 toggle switches there. It will control, first is coil, second is printer, third is drive. When you are going to run, you should start this order. First is coil, second is printer, and third is drive. Drive have this one toggle switch can act forward and base because it is a two-way switch. One is right side is forward and left side is reverse. Next is paper control or chart control. Push button will help you to release the chart paper, and this potential meter will help you to adjust the speed of chart. You can run the chart in fast condition or slow condition. If you are running slow condition, you can save the paper. You have to calibrate the same speed. Each graph have 4 sections. First is odd number, second is even number, and third one is SCS level, and fourth one is wall monitoring. And there have a small divisions. In each column contain 5 small dots. The height of each column is 25 mm. So the small divisions you have to consider 1 mm. The big section is 5 mm. Total 5 boxes you can see in the graph. That means it was 25 mm. If you keep in this calculation, you can easily achieve the calibrations, and you can easily interpret the graph also. The manufacturer is saying, in Newtek is saying, the each value is mils, means 1 mm is equal to 39.37 mils. Next is wall monitoring system. Buzzer on and off toggle switch, and baseline toggle switch, threshold line toggle switch, and baseline potential meter, threshold line potential meter, then gain and zero. That 2 potential meter will control the wall monitoring setup. 4 section shoes have each control. 1, 3, 5, 7 have one section, gain and zero. Then even number have shoe number 2, 4, 6 and 8 have 0 and gain control. And both the section on and off toggle switch. These are the wall monitoring setup. And also they have, in this location, have the buzzer on and off toggle switch and buzzer. Buzzer is a audible alert and LED is a optical alert. Next is graphical representations, means graph. In graph have 4 section. First is odd number shoe indication. Second one is even number shoe indication. Third number is SCS level indication. SCS means signal conditioning system level indication. The pipe have no evidence of defects or transverse defects or pitting, cut, gouge, anything. If there is no defect, graph will move from left to right smoothly. If have any defect, there will be a kick, any cut or gouge or something. Defect you have to investigate later, but the machine will show you there is a defect or there is a material discontinuity. If have any cut, the flux leakage will come out. A shoe is crossing the flux leakage, then there will be producing a small amount of electricity that will amplify, and a chart will indicate you, chart will show you there is a something, some defect that you can get here. If the kick height is depend on the magnetic flux leakage on from the defect, and speed of the buggy head, the speed of the buggy drive, and magnetic current of the coil. If you give more ampere current, the coil can produce more magnetic flux. So the more magnetic flux, if there is any defect, the amount of flux leakage will be high. Then here will get a huge kick. So always you have to investigate again what is that defect. In graph, which shoe is detecting that defect, corresponding which light is glowing, the corresponding shoe is detecting the flux leakage. So you have to check that only that place. If your buzzer system is on, your buzzer is on, then it will that time will get a beep sound, or multiple LED will glow. Then you have to assume more than one shoe getting flux leakage, means there is a defect. It was maybe half round cut or something, means 2 or 3 shoe will pass defect, then magnetic flux leakage will making the electronic current on shoe. That time in graph you can get it 2 or more kicks, and the optical indication will also show, the buzzer will also beep. So you have to assume more than one shoe crossing the flux leakage. Any signal is passing the SCS level, then that signal will register, or that signal will show on that third section, SCS level section. You can adjust the gain to increasing or decreasing the height of the kicks. Normally it will place on 10 mm, because when I am going to inspect the pipe, I will place above the threshold level. Then we can ensure that the signal is passing the threshold level. Which kick will pass the threshold? If the light will on and the buzzer will make a beep sound. The bottom section, the valve monitoring section also have the threshold. Then which signal is crossing the threshold, the console will indicate to the inspector through optical and audible. Optical is two LED lights will glow on there, and the beep sound will come. second section is wall. So first off, we have to calibrate a transverse flow. So place the buggy and coil on before starting the hole. Then second is align the shoes on each holes. Means the first shoe will pass first hole. When you place the buggy, then first shoe will be back and second shoe will be front. So in between first and third, there is a gap. You can look that gap and align the first hole. If you align the first hole, all others will align automatically. The width of each hole is same. So if one shoe is aligned, all other will automatically align. There is an easy way. First of mark the full penetration holes and put the number 1, 2, 3, 4, 5, 6, 7, 8. The first number shoe is always behind of the drive. You can look in between 8 number shoe and second number shoe. In between that there is a gap. You can place that center of the shoe in that hole. Then this become align. The first shoe will align, all others will align automatically. So main important point is to align the first shoe. Mark the first hole and place the coil, place the buggy head and coil. Then look where is the first shoe. The center of the first shoe will pass through the pipe hole, full penetrated artificial defect. So all others will automatically align. These are the first step. Power on the machine, switch on the coil, then it will show the connection is okay, it will show the ampere. If ampere is not showing, you have to check the variac will be 0. So then move mag control forward base, then increase the mag current, it will show the ampere. Then ampere is showing, connection is okay. If the connection is loosened or you didn't connect properly, then the ampere will not show, mag will not be switched on. These are the basic troubleshooting technique. If the mag is on, ampere will show, magnetic field will be there. Variac, the potential meter or variac, mag control is 0 or cable is loosened or broken something. And next is check the chart, just run and off. Chart is working, it's okay. Means the chart is moving from right to left. There is a take up or a chart receiver or chart take up is there. That will wind the chart. Coil is okay. Chart is moving. And third one is buggy control. Buggy just move forward. If buggy is not moving, then your cable is loose or your buggy speed is 0. So check these two things, buggy speed and cable. 3 breaker is there, one is drive and coil. If any short or something, the breaker will off. So in that circumstances also have to check the breaker in coil case and drive case also. Not moving, first check the breaker, then speed, first check the speed. Speed is 0, buggy never will move. So increase the speed. Then there is no movement, have to check the breaker. If breaker is okay, buggy speed is high, then buggy is not moving, you have to check the cable system. That is the buggy troubleshooting technique. Then to adjust the speed, which speed you can easily run it, you select the speed on calibration block and move forward and backward the buggy. Then buggy is okay. Right now your buggy head, coil and drive, everything is working because it can move forward and reverse on the calibration block. Next is transverse flow adjustment. Next is transverse flow adjustment. That means total 8 number of shoe. We have to calibrate all the 8 shoes. Calibration standard pipe. They have full penetrated 8 holes. Each hole have 1/16 inch diameter plus or minus 1/64 tolerance. And the pattern of the full penetrated hole is spiral pattern. So we have to calibrate. Each shoe have 1/16 inch diameter. The equal amount of flux will leak from that hole or from that material discontinuity. We have to adjust each shoe and graph is same kick. All the kicks should be same height. That is the calibration. Three technique have to calibrate this section, transverse flow section. First is you can calibrate one by one. Switch off all the toggle switch, then on the first number. First number should be 1. The 1 number will get the kick in on top of the chart. As per the DS1 standard, you have to adjust minimum 10 mm. Always I am selecting 15 mm because it will get maximum height. We can separate from the noise. 15 mm is I think better, and give the appropriate mag current. You can increase or decrease the mag current through that variac. Variac means a magnetic control. There is a control on the right side of the console. If you rotate forward base, increase the mag current. If you rotate reverse base, mag current will decrease. So give the appropriate mag current, 2.5, 3.5 something is. Second step is move the buggy forward base on the standard pipe. Then you can get it a kick. It will not be 10 mm, maybe 20 mm, maybe 5 mm. Then you have to increase the value. Before you rotating the potential meter, there is a lock system. You have to unlock. Means if you turn anti-clockwise, it will off. The lock will off. So before starting the calibration, you have to unlock all the potential meter. Always set the threshold above the kick point. Hold the threshold key, adjust the control on above the kick point. Kick point means you assuming your all the kicks should be 10 mm or 12 mm or 15 mm. There is a value. You decide it already. My kick means my kick point is 15 mm. So you have to place your threshold 15 mm. Then the kick will crossing the 15 mm threshold. Then the optical and audible indication will get. The machine will alert you. The kick is passing the threshold. Then you can easily check which shoe is passing the threshold line. Then you have to investigate that the particular shoe side. Then you have to decide your kick point is 10 mm or 15 mm. I am taking here is 10 mm. 10 mm is my kick point. Then my threshold is already set at on 10. My SCS level is already set at on 11. Then if the kick will not pass SCS level, there is that SCS section will not get any kicks. If kick is passing the SCS level, you can get it the indication on SCS level. Then you can adjust the gain control to the maximum height. Means if you rotate the SCS gain control forward base, the kick height will increase. If you rotate reverse base, this will decrease. So next step is, if right now you go to the single kick on 5 mm, you have to increase some value, blindly increase some value, then run the buggy head reverse base and place the first position. Again check the alignment of shoe, then run again. Then you can get it 12 mm. So your kick point is you assumed in 10 mm, it was 12 mm. So run reverse again, adjust little bit, reduce the gain. Means rotate the control on anti-clockwise, then it will reduce. Achieve the 10 mm. Again run it. It will on 10 mm. It's okay. Repeat this setup all the 8 shoe. In first method, switch off all the shoe, then calibrate single shoe, the first shoe. If you are calibrated the first shoe, then off the first shoe, switch on the second shoe and repeat the same setup. Then increase the value or 1 or 2 point in potential meter. Then run it. Then you can get the kick from somewhere. Maybe it will be 10 mm or 20 mm something. You adjust the value and run reverse. When you are going to run, first mag is on, chart is on, then run the buggy. Buggy is passing the first section, then stop the buggy, stop the printer, stop the coil, then run the buggy reverse. Second method is you can off all the signal, then you start it 1, 3, 5, 7 odd number, then give the same value on each potential meter 1, 3, 5, 7, then run it. Start the coil, start the printer, run the buggy, then check where is the kick point. So you adjust the each value to achieve the height on your kick point. Is we already assumed kick point is 10. So adjust the kick height 10 mm. Then switch off all the odd numbers, then on the even number 2, 4, 6, 8. Then repeat the setup. Then if 3 run, 4 run, or maybe 5 run, 6 run, you can get the accurate value. Before you running, always remember your shoe should be aligned on same way. If misalignment, you can get it wrong kicks and wrong value. We already discussed in second method. Switch on the odd number 1, 3, 5, 7. Calibrate the odd number. Then switch off all the odd number and switch on the even number. Then repeat the same setup. The third method, this also I am using. Switch on all the shoes. Before starting to calibrate, your buggy head should align the hole. Each setup is same. After completing the buggy drive setup, switch on all the shoes and adjust the mag current. Then give the same value on each potential meter. I am setting 5 and run the buggy. I am also adjust the speed before running the buggy. Then run again. Then you can get it the kick on 5 mm or 8 mm something. Kick point is already set in 10 mm. So increase or decrease the same values. Means if the kick point is getting 20 mm, you have to reduce certain amount. Then run is to achieve your kick point. To adjust the value. Then if you're running approximate 2 or 3 times, you can get all the shoes in your kick point 10 mm. Very easy method. And it's a very simple one. Switch on all the shoes given a certain value. Then switch on the mag, switch on the printer, run the buggy head and check the value. Where is the kick? Adjust the value. Once you achieve all the shoes are 80% aligned, then your this transfer section is okay. The procedure is saying 80% accuracy is okay. But if you calibrate the same speed, same current, same voltage, you can get it all the shoes in same value, same kick height. I am using this method. It is very easy. Next is wall monitoring setup. Also have 3 methods. Before you start your base, check your baseline. Hold the baseline toggle switch and adjust the value 1 mm. In between 1 to 5 mm. 1 mm is okay. You can get it maximum accuracy. 1 mm or 2 mm from top. Always remember from top. All others are we set up from bottom, and this wall monitoring section is baseline is set up on the 1 or 2 mm from the top. Before starting the wall monitoring setup, you have to align all the shoes. Don't place the buggy head on the wall loss area. Then switch on the mag, hold the baseline toggle switch, run the printer. This time mag is on, printer is on. Then adjust the value 1 mm or 2 mm from top. Then your baseline is okay. Second is threshold. Switch on the mag, switch on the printer, then hold the threshold line toggle switch, adjust the value from 10 mm or 15 mm or 5 mm below the wall monitoring layer. 10 mm is better. I am also set up the mission on 10 mm. Your threshold is 10 mm. the same, these are the basic setup. Three methods have it to calibrate the wall monitoring setup. First is switch on the wall monitoring section 1, then run the chart, adjust the zero and gain to get the wall loss kick, wall loss indication on graph. If you get it on middle of the graph, the kick is not passing threshold, you have to adjust the gain. Repeat the same technique to second section. Switch on the second one, adjust run the chart, adjust the value. After completing these both setup, you have to switch on the both toggle switch and run it. You can get it the value on proper place. This is the first method. The second method is on the both toggle switch, adjust the same value 0 and same value gain and run it. If you getting the same wall loss area below the threshold or above the threshold, after that you have to adjust both value, the same value gain and 0, then adjust the wall loss curve on the graph. It will take too much run and too much time. This is the second method. Next is third method, very easy method. I am always following this method, third one. Initial setup all same. To adjust the baseline, adjust the threshold, adjust the baseline on 1 or 2 mm from top, adjust the threshold on 10 mm or 5 mm from bottom. Switch on the mag, give the certain value to 0, 1 or 2. That's depend on the pipe. Audio control, audio switch means a buzzer switch and optical switch always should on. Then which point the light will off? If you are adjusting, you give the gain 2 or 3 point, then on both the control, give the gain 2 or 3, then adjust the 0. When the light is off, keep that point. Then repeat the same technique. Give the gain value 2, 3 or 5 or 6 something. Adjust the 0 on clockwise. When the beep sound is off and light is off, keep that position. Then you have to run. You can get it a perfect wall monitoring calibration graph. If the graph is not passing the threshold line, you have to increase a little bit gain. It's a very easiest method for wall monitoring system. Then you have to run 4 times on pipe. There is no changes, same amperage, the same voltage, same buggy speed. 3 or 4 run, you can repeat the same setup. There is no changes, or changes is should be below the 20%. You can run on the pipe. These are the easiest calibration technique. Thank you for watching Rig Tech.
It's okay. Don't want the crew.
Okay.
Morning.
The other side.